Hello everybody. I guess it's time to get started. How was everybody's day? Hope it was good. So far anyway. Today's been pretty good for me, nothing eventful, but it's so hot here. It's supposed to be February and it feels like May. But I guess I shouldn't complain. Anyway, so today I've decided that I think I do want to fully support at least chess and checkers in this game. And so in order to support checkers, we need to support multi-part turns. Because you have to think of basically each jump over a piece is one turn. Or one part of a turn anyway. So the player will basically get to move once and then try to move, give the option to move again, and if there's no possible moves then the turn would be over. Luckily that means we don't need to actually add much logic to the possible moves calculator that we worked on yesterday. But we will need one thing. Basically, here we support like this table can only run if it's the first move for that piece, but we also need to support this table can only run if it's the first move of that turn, because with a checker you can move forward if it's your first move, but then you can't move forward after you've already jumped over a piece. So we could add another field here, but under the piece object for a number of moves in turn or something like that, but it seems a little counterintuitive, or not really counterintuitive, but a little bloated for this class because it shouldn't really have to keep track of that, in my opinion. So that seems like more something that the turn manager would do. What should we call it? Maybe sub-turn number sounds fine. But the move option calculator, I don't really want it to have to look that up in the turn manager. So I think it should actually just be past it. But in order for us not to have to add another argument here, I think we should change the argument type to maybe some custom structure. How about, we can just call it calculation, spell it right, calculation arguments. It would be send the behavior ID, the position, the let's say the move number for the piece. How should we label that? I'll say num piece moves, and then also turn moves. And so now instead of passing these arguments, we would just pass this one calculation args object or structure. It also decouples this from the piece data, which is kind of nice. We'll just pass the args instead of having to do the piece every time. Same thing here. Oh, actually, yeah, we still will need to have the yeah, we'll need to have the position, of course. Let's just revert that because I can't remember. Okay, you did call it using quotes. Because this position changes and it doesn't always use what's passed in the arguments. Okay, so now we just need to change this from looking at the piece, and it'll actually use whatever was passed in the arguments. Okay, and we also need to know the owner player. So now I think everything is set up. And then here we would just add something else. Let's call it I think we since we'll have two types of this, we should change it. This a name for clarity. Let's call this before piece moves, and then we'll make another one that's before turn moves. So if this table has a before turn moves entry or requirement, then we'll need to check that. Up here, oh yes, we just need to pass position like that, and then it wants us to update this the type arguments. So now, of course, any place that called this would also, we also will need to update the type arguments, so let's go ahead and do that. Luckily, the only place we have it so far is this move tester. So now, instead of calling it with by passing the piece, we would actually pass the calculation arguments. So we'll just do the same thing as we had before. And the player is player 0. And now we can go ahead and test it, and we should get the same output that we did yesterday. And we do 4-3, 3-4, 5-4, and 4-5, which is every position around 4-4. So now we have that and all set up. Should go ahead and how about link this up with the turn manager. Oh yeah, we did this in the turn chooser class. Let's go ahead and just to refresh our memory how it works, we'll do one turn. Now it should let us choose this piece, and then we can, so it'd move piece to 5-2. How? So we need to do the piece mover object. And we'll just simply have it move the cube to the position for now. No fancy animations or anything. In the right namespace. Okay, so we'll open up our little object diagram just to review the structure we'd set up before. Okay, so the turn chooser should return its the choice to the turn manager, which in turn tells the piece mover to change the position on the board. But right now the turn chooser doesn't actually do anything except give us a debug string. So it needs to send back the chosen piece and the chosen position to the turn manager. Let's see, how would we do that? Let's just make another struct kind of like we did for the path calculator. Okay, and now we can just make another event that when the turn is chosen, it will notify anybody who cares about it. What would that event be? That looks good. We'll just add this as a component, just like everything else. Need to do a new key. Let's call it move choice made. Sounds good. And that's all we have to do for that. Now here, we'll leave the debug string for now, but we can go ahead and call the choice made event. So the piece would be the chosen piece, which we remembered from the previously. And then the space is the square position from the selection event. So now we can have the turn chooser subscribe to that event. Yeah, I think that's the best thing to do. The other option would just be to have the piece mover subscribe directly to that event, but we might want to have the piece mover move pieces in some other way, so we should probably make something separate for it. In fact, let's go ahead and do that. Oops. Oh, did I misspell that wrong? Oh, I think it says chess scene. I'll go ahead and close that. Okay. Now we'll make another, it will actually basically be a remote function like we did for the move option calculator. Go ahead and just copy this. And then should we make another? Yeah, I'll go ahead and make another struct. In case, this is always good, in case you have to, you might need to increase the number of arguments in the future. I could see us moving away from sending just a piece ID and a position, because we might want to tell the piece mover to also move the piece with a certain animation, or maybe also send it the piece that needs to be taken off the board, things like that. But for now we'll just send it the piece ID and the position to move the piece. We'll just have it return a boolean. Might as well. Just tell if the movement was successful or not. And so we'll have another janitor. And another component key. Let's call this one move piece command. Oh, and here it's complaining because we don't have a callback. If we tell it to generate a function, it should go ahead and do that for us. We'll just have it always return false for now. Okay, so now if we go back to the turn manager, we can tie everything together. Now one thing we have to be careful about is since the turn manager and turn chooser rely on things that each other, like the turn manager relies on this choice made event, which is instantiated in the turn chooser constructor. So as of now, the turn chooser is instantiated after the turn manager. So if in the constructor of the turn manager we decided to look at the event, it would still be null. So we need to wait a frame. A simpler way to do it is actually something like this. And then we'll just have, after everything's instantiated, we'll have a turn manager. And we can do this for any object that might need it. The other option would be to have the turn manager wait until the next or the first update, but that's a little messier because you have to think about registering and unregistering and from the game update list. Anyway, we'll need that reference over here. Okay, so we'll actually need a listener, janitor. Argument for this will be the turn chooser dot choice. And the component we want is a messenger turn chooser.choice, and it's under the key choice made. Yeah, move choice made even. And we'll just make a new simple messenger or a simple listener. Handle choice made. And we'll go ahead and just have it create this method for us. Now what we'll do here is it will then call the piece mover. Alright, we'll call the piece mover remote function to actually move the piece. So we should have that, a reference to that. We can go ahead and get that over here. I'm just going to copy and paste this type. Bad thing about generics is you start to get really huge function calls, but it's very useful for not having to cast objects at every turn. Okay, so piece move command. Now this will just be simple. And we'll basically just move over the arguments from the turn chooser choice to the piece mover move command. And we're not going to do any validation for this at the moment. So all that we'll do, well, first we need to get a reference to the board. And we know from previously that the board will be null if we try to get it right here in the constructor, because the board is not created right away. So we need to add this event to listen for the board created message, and then we'll grab the board here. So all we're going to do is say board pieces command piece index dot board position equals the command move to. And let's go ahead and send a debug log. Piece index and move to. Now I think, oh, we need to instantiate this piece mover in this scene, of course. Let's see, does the piece mover need anything? Oh, it needs this board created message. We might need to have this register events pretty soon for everything. And then we'll just have it call it'll just be called, and then we'll just move most of these event registrations into those functions, because we're starting to get a bit tangled with instantiation here. But when we run this, internally the piece will move, I think. Yeah, moved piece 0 to 5-2. It's strange that. Oh, that's funny, we just use the exact same message, but oh, this one actually is what the turn chooser printed, and the other one is the turn manager, so let's just add a choice here to differentiate. But obviously the piece didn't move graphically, so and that's something that the Unity engine needs to take care of. Right now the piece model doesn't do anything except hold the piece index. And that's probably still good. Okay, for now let's just make a simple object. I'll just call it simple piece mover. And we probably won't use this in the final game because we'll want to have animations, but this isn't going to have any animations, as it's going to move the piece immediately. Okay, so we need to have some kind of event. And we could go two ways. We could either have a separate event for each piece, or one event that's thrown for any piece change. I think that is probably better, especially since the piece mover, we're going to have it handle all movements, so we don't have to worry about it being called from multiple places. So let's add another event here. And it will actually just pass the piece index. Because anything that wants to look up the new position, they can just grab a hold of the piece object. I'm sorry, my internet has not been that great today, so I apologize for the drop frames. Hopefully it will level out pretty quickly here. Okay, so yeah, we do need to add a component janitor. Let's call this piece moved event. So now we just send the piece index here. And then the simple piece mover, it will just register for that event. How did we... Okay, we just created this activatable list. Well, since this isn't, the simple piece mover is not going to be a final thing, we don't have to worry about cleaning up too much. Can't spell. Oh, this is a simple listener integer. Our callback will be on piece move. I'll just have it generate that for now. Then need to register that listener in the event. So game components. Okay, we need to use the moddable chess. Game components. Oh, it's component keys, not game components. Yeah, there we go. Piece moved event. And then subscribe. There we go. I will also need a reference to the piece model creator because it will hold all of the models that we'll need to change positions of. So for now it's actually private. Let's do that for now. Again, I'm kind of doing this lazily because this is not going to be a final implementation. So if we get the model, then these models are just Unity objects, so we can just set the transform like this. Okay, so one problem here is that, well, one, we need to get that piece object to find the position, and also we have a scaling factor to transform the board space position into actual world position. But first we'll handle getting the board. I'll go ahead and copy this. Oh, here it is. But we won't worry about the janitor. Let's go ahead and cache the reference just to make this a little clearer. Okay, too many. There we go. Is that the right parentheses? I think so. So now we can get the piece. Can't remember exactly what the scaling factor is. For some reason I'm thinking it's 3, but I'll just go ahead and go with that for now. We'll just have it preserve the Y. Okay, so there we go. Not sure why I did that, but we don't need that right now. Oh, it was for testing. Yeah, so we'll leave it. Okay, and it doesn't need the board anymore either. Just getting rid of some of these warnings. So let's see what happens. Oh, I forgot to get the models. This find model of our object of type. This finds this component and some object in the scene. Since we only have one, then we know it'll always get the one we want. Okay, it did work pretty well actually. It's a little bit transposed, but seems to always go onto the corner. But I get the idea. If we subtract 1.5, I wonder if we'll get get it to be in the center. Yeah, that is pretty close actually. We change it to orthographic. Oh, it is exactly in the center. Alright, turned out nice there. Okay, so good. Now we have a way to test which objects, or to test the position of an object graphically. So now one thing we might want to do is maybe display all possible movements for a piece on the board. For instance, in some games it would highlight the squares you can move to. Now right now since the board is going to be basically a moddable moddable model, I don't know if we'll be able to, like, in order to recolor this square, for example, we'd have to access the UV coordinates of this texture and change them, or of this model and change them. But if we allow people to import any model they want, I don't know if there's an easy way to do that, especially because they might not set up the UVs for each space. So another option, of course, is just overlay another model on top of any place you can move to, which I think is probably what we'll do. So the turn chooser, let's go ahead and clear out this. So what it's going to need to do is get the list of possible moves for the piece, the selected piece, and then send out an event that Unity can then grab onto and position the indicator models as needed. So maybe like when we hover over a piece, maybe it should show the movement options for that piece. And then definitely it should show them once the piece is selected. So the first thing we'll need is a reference to the move option calculator remote function. I just realized one problem. As I was typing this out, this is a bit of a it's a program structural problem, but I realized that the point of the remote function is to try and decouple the turn chooser, for example, from the move option calculator, but by using this internal class, we still couple it because it has to call move option calculator dot calculation args. So we'll just have to keep that in mind in the future. I won't worry about it too much now since it's just a prototype, but probably a better way to do it would be to make a separate class called like move option calculation args, and then that way you still can keep the two classes decoupled. Anyway, back to what we were doing. Then yeah, we'll need a list. To cache the return value of this function. And then we'll also need and this will be the display options command. So let's go ahead and set these up. Let's see. We can move this up here actually. There we go. What do we call this? Move option list query. There we go. Right. So now we have a reference to the calculation function. Spelled that wrong. Let's go ahead and create the list. Then this display options command. Just copy this. Sure. We need to have a new component key. Okay. And we'll go ahead and send an empty list in case anything that's subscribed to it needs to be initialized. So now we actually need this on selection change again. because if we're in the choose state, what is it called? States. If we're in choose piece and a piece is selected, we want to show the move options for that piece. Should also probably only show this if the selected piece is ours. Oh, wrong thing. Okay. Let's make a separate function here. So actually, these calculate positions is assigned everything, so we don't need to do this. So the piece ID. Okay, so we don't actually send the piece ID, I forgot. Instead we send information from the piece, so won't work with me here. There we go. So the behavior ID is the piece's behavior ID. And the position is the piece's position. And same, the owner player is the piece's owner. Pieces moves as the num piece moves here. The only thing that's not the pieces is the num turn moves, which we'll just set with 0 for now because we haven't figured that out. And then after we calculate the positions, we'll go ahead and send out the display options command. And we'll also do the same thing here. And once this has happened, we'll again send out a null. And then we should also send out null. If the a piece is not selected here. So yeah, we need to change this. Okay. Then, yeah, because if we're not in the choose piece state, we don't want it to refresh the move options at all. But if we are in the refresh move state, we want to send the pieces move options if this is true. Otherwise, just send no display options. All right. Okay. I think we're done here, so let's go ahead and move over to the Unity side of things. Say move option. Move option models. Again, need to set the right namespace. Okay, so here we'll want a reference to the prefab for the whatever model we'll have here. And again, the prefab is just an object that Unity will clone for every model that we need. And we had this problem with a simple piece mover. Well, we'll get to that in a second. For now, let's go ahead and create the models, and we'll worry about where to position them when the time comes. So, since the models will be hidden and shown frequently, we don't really want to have to keep deleting them and respawning them, so we'll keep a list of let's do game object. A list of active, or I'll say alive, and then a cache of hidden. So the first thing we do is we need to subscribe to subscribe to what? Oh, this display move options event. So first we'll make a listener. Then we need to say that we're using those namespaces, of course. Let's call this, I don't know, options change. The reason we do this is because we can listen for this Unity event, and when that happens, we can just dispose of this. That'll clean everything up. Or rather, we need to unsubscribe. What's going on there? Oh, one too many spiky bracket. Oh, that's confusing. So component keys. What do we call it? Was this change? No. Oh, display move options. And just unsubscribe from this listener. And similarly up here, say subscribe. And then the options change listener. Let's create a method there. Okay. So now we have a list of all the spaces where we want a model to be placed. First thing we'll need to do is populate the alive list with all of the models we'll need. So let's do this. We'll create the model. Does that work? They added that generic argument rather recently. Used to, you always had to cast. We'll go ahead and set this object as the parent just to keep the scene clean. And then add the model to alive. Similarly, okay, we actually need another option here. If visible options is null, then we just need to add everything to the cache. We just have, instead of using a dot add, you use dot push for stacks. That's just kind of the tradition, I guess. And then we need to disable this object. Otherwise we can run this other part that we were writing before. As I was saying, similarly, if the alive list is larger than the visible options, then we need to delete some. I really don't like using while statements. I think this might be better. This is really the same thing, except there's no way you can accidentally mess up and have an infinite loop. Which happens very frequent, or not very frequently, but too frequently. Does that work? return anything, so we have to do this first and then remove. We should actually do it this way. And then while I is greater or equal to the visible object count, we'll just remove stuff. Okay. Just looking over it real quick to see if I notice any errors. I think that's correct. And so now that we know that we have exactly as many models as we need, so we'll leave one more time. So really all we need to do is something like so here we would set the position. But I think as we found with the simple piece mover, we should move this function somewhere else, because I think many objects are going to need to have this logic. But first, I did just realize that the whole point of the cache is that if there's models in the cache, you don't instantiate something new. So let me change this. So if the cache is not empty, then you just do this. That way you don't have to keep on creating new models every time you do this. Creating and destroying models can get very slow in Unity, so you want to try and avoid it. So where should we move? A lot of times when I do something like this, I would move this to a static class, because it's really easy. You don't have to have some kind of remote function like we did for the other instances, because it doesn't rely on anything besides constants. I'm trying to think of that. I'm pretty sure that's still valid here, so I mean, we can always change it, but again, setting up the namespace. Not really sure why Unity encourages you not to use namespaces, because it's really just a good practice. But actually, I think I remember in older versions it didn't work very well, but they've since fixed it. Anyway, so this is just a static class, so we do something like this. And we'll just use this formula here because it works perfectly. In the future, we'll probably Probably want to do something a little less hard-coded, but that's a good thing about using this function, or some common function like this, because it's easy to make changes to the way the data is stored in the future if you need. So now all we do is call it like this. Similarly, here. Okay, so let's go ahead and set this up. Let's call this move options. Oh, the indicators, how about? And then we need to make a model. Let's use a modified version of this. How about we scale it down? And then we'll move the prefab back up here. Oh geez, sorry about that. I'm not. Seems like Windows is maybe downloading something without telling me. It's really annoying when it does that. It looks like things have evened out a bit now, so hopefully smooth sailing for the rest of the stream. So let's go ahead and test it. Okay, and yeah, something can't work on the first try. Oh, we forgot to add the... Oh, we didn't instantiate this alive list, so it's an easy fix. Okay, argument out of range, what's that about? $49. Oh. Okay, and it does work. It's really nice, actually. Okay, let's get rid of this debug, because it's cluttering everything up. We don't need it anymore. Okay. Then when we click, they should stay up, and they do. Now, of course, we still don't validate. Oh, it got into there. No, it was no big deal. They still are, the chooser doesn't actually force you to pick one of those positions, but oh, I see. We just need to, yeah, this layer is set to pieces, so we need to move it to default. and then the raycasters will ignore it. Yeah, there we go. Cool. Okay, so now that we have that figured out, I guess we should move on to the multiple piece or multiple move turns. So what happens here? Interesting. So taking checkers as our example again. Let's just simplify it and say that we have two move tables. The one move table is always move forward. And if that happens, the turn is just one step. But then if you have the other move table, which is to jump over an enemy, then you could have multiple moves. And so now for every move option, we also need to have the game know which move table it picked that option from. Which right now we don't, because the move option calculator only returns a list of positions. This also, another question is, what if you can get to a position from two different tables? It doesn't happen in checkers, but since this game is you're gonna be able to define all different types of movements. Should the player be able to pick which table it uses? I don't know, I don't think that makes much sense. Okay, so where's the object move option? Oh, piece movement data. Let's see. I think what we'll need to do is in the turn option calculator, it will just use like whatever table, it will go in order. So for checkers, turn the table 0 would be just the normal move forward option. And then table 1 would be the jump over option. And if, for example, some other piece had it so you could reach a certain space from two separate tables, the game would just force you to use the first one. I think that probably makes the most sense. So I think we should probably add another argument here. Let's call it original table. That's just T here. And it will always just be passed down. And instead of possibles just being in vector 2, we need to actually create another class that has the int vector 2 as well as the table index. So let's go ahead and do this right and just make another separate class. Let's say, what should we call it? I guess this move option. And this can just be a struct, actually not a class. Space, and then well, let's just call it table. Going back to the calculator, we need to change this list actually to be a move option. And then, so we can't really have this be a hash set of move options because we actually just want that to be one option per space. So we should still keep this as an int vector 2. And really, so that we don't have to keep passing around these things, let's just make it make it a reference here. Okay. But we can create the visited spaces here actually. Oops. Okay, so now we're not going to pass these around all the time. We'll only recurse down if the visited spaces does not contain the space. Oh. Then we'd add, first we'd add it to the visited spaces so it won't be, so we won't accidentally go through here again. And then we add also an entry into the final options. And then the table is the original table. And then we recurse farther down. We'll just leave that as it is. Okay. So now, of course, anything that use this move option list also needs to be updated. Which luckily there was only a couple. Okay, and then turn chooser. Okay, there's an error. I was gonna say. Okay, so the calculated. Now, should we send? Should we send the data about the tables to the display options, or I'm not sure it cares really. So yeah, I don't think we will. We'll just go ahead and make a new list here. Oh, this is called spaces. Okay, we should actually change this to calculated options. Can't spell. And then just add. Oh wait. There we go. So now we just make a list of all of the, a list of all the spaces, and we just basically throw out the table data because this display options does not care about it. Now that we have that, so we'll have this flag here to allow multi-turn, so that way the game will know if it uses table, we can allow another turn. Okay, so now, what's the next step? So the turn manager, so it's done the move command. Now what it should do, it needs to move to the next turn. actually it's the match manager that is the part that decides when a turn is over. Well, no, it just says when to start the next turn, so I think the turn manager will decide when that turn is over. So again, this move command, it will also need to tell us the table. Oh no, this one. It's the choice that needs to. Too big. Or too many files open. There we go. Here it is. Behavior move index. Or behavior move table, I think is what we were calling it before. So then the next thing we do is when we send this option out, we'll also make a note of the table. So we might as well go ahead and make sure that we actually select Cebu of movement space that is actually given to us by the move space calculation. And while we look for this, we can go ahead and have it return the move option. So here all we have to do let's go ahead and let's see, calculated options. So we'll loop through the calculated options, and if we find one that's on the same space, then we know it's a choosable space. So in this case, found is true, and the option equals O, and then we'll break the loop. If found, then we turn true. Okay, what does it not like? Okay, well, the option is always assigned if found as true, but it doesn't know that, so we actually don't need to do this. Let's just say option go to default. And basically if it makes it through the whole loop, we know that nothing was found, so we'll just return false. Okay, so here return the selection event square position. Okay, we need to define that. Oh, I forgot to open the brace. Okay. And so now that we know the table. Okay. We might as well test what we've got so far. So the biggest thing is that now it should not let us move over here, which it does not. It's good. Might as well go ahead and add a debug log. Okay. So now we go back to the turn manager. So here is the callback for when the choice is made. First it moves the piece, and now we can check. Okay, well we need a list, or we need a reference to the game database. And then, oh, what did I do? So if database behaviors. Oh. Okay, so we also need the board actually because we need to get the behavior ID. And we know to get the board you need to listen for that event. Let's see, does this do it? Okay, yes, right here. Okay, so let's just say piece equals board pieces. And then table. If this is a multi-turn, then we need to start another subturn. So we'd say subturn number, we'd increment it. Speaking about that, we should set the subturn number to 0 here. And then we'll just say start choosing command again. again. Okay, so the turn chooser needs to know, now it needs to know the subturn because it has to pass it right here. So we should make just another simple little right here like we did for the turn event. Do the same thing, sub turn event. I'll just copy and paste this because it's almost going to be the same. Make another component called the current subturn. Oh. No, I don't want to rename it. There we go, current subturn. Go ahead and update this here. Really, no reason to have I think this might be better actually. So now we didn't need to have a separate integer and the event, so now I just combine them. It makes it so we don't have to worry about updating them separately, because we'd always want them to be in sync anyway. So now all I have to do is say turn value subturn value is always 0 at here anyway. And then we'd increment it here. So now the turn chooser just needs to get a hold of that subturn. What do we call it? Subturn, yeah, current subturn. And then here, when it calculates the moves, we just take the subturn value. That's basically all we have to do. So now I think we can implement checkers exactly, because we have support for different movements on the first turn, or the first subturn, and then our infinite movements afterwards. So yeah, I think we're good. There's one nagging like functionality I keep on thinking that we should add, to where if we get a multi-turn from a table, that we should remember what table it was, and then that might influence future subturns. but we actually don't need that for checkers. And so right now I just want to make sure we can implement chess and checkers completely, and of course we can see if there's somebody thinks of some really good mod idea, we can add some more functionality. But again, this is mostly just a prototype because we want to test. I wanted to make a game using the modding and multiplayer tools before we actually try to make a complete polished one, which will be our Pokemon / Fire Emblem / Final Fantasy Tactics game, which we should get to in a few weeks. So I think, fortunately, I don't think we can't really test sub-turns now because, yeah, it doesn't let me do it. But I guess we could just, well, obviously, we can test it, obviously, because, let's see, where did we make the board? Oh no, it's just in the game data. In the game database, we just need to make one of the tables allow, we just need to make this table allow subturns or multi-turns. So now, yeah, it should let me choose it again. Okay, so that is a little weird because I don't know if you can tell, but if you notice what's happening, but it lets me, if I could select this piece, it would let me pick any piece I wanted, but really, for multi-turns, you always want to select the same piece. So that's something we need to add. Basically, if the multi-turn, it just starts with that old piece selected. Okay, so let's see. If subturn is equal to 0, then we set all this stuff. Oh, subturn value. Else set the state to choose action, and this chosen piece is still left over from before. But this does seem a little hacky, so let's see if we can think of a better way. Of course we could just say make a separate event, but how about we change this start turn choosing command and make it have a separate argument for the first piece. And if it's -1, it means the player can choose. And so instead of this being the subturn, it just is if piece is less than 0. Otherwise, we basically want to copy this data. So let's pull out this. Let's call it start move phase. And we'll just pass it. Pass it the piece. Oh, well, we called it action before, so we'll say start action phase. And this is this cell event, selection event, piece ID. And then here, it is the piece. So we should always just set this, actually. So now, okay, what's wrong? Okay, we just need to, there we go. So now this first turn, it should let us choose the piece. And so now the piece is chosen, but we see it's not updating the indicators. So why is that?
Look out! The last thing you remember before blacking out was a shadowy figure approaching in the road in front of you. You heard your sister cry out as you swerved the car into a tree. You now realize you are alone.
Oh, okay, it's because, okay, this is a little confusing, but the choice made event is sent before the display options command. And so it sends this, which calls this function. And then it calls this again, which goes back to the turn chooser, which calls this, and then the game returns here and sends a null list, so it overwrites the these options that we'd want to send. So we just need to move this up above it. Okay, so yeah, now it works, right? And you can see we start with the piece selected. I'm not clicking on it again, which is how we want it to be. Okay. Oh great, and we're at a great stopping point, and it just turned 6. So we completed our goal and everything. So tomorrow we'll continue. Well, if I have time, I might think about starting our research game, which I'm thinking might be one of the older Fire Emblems or Pokemon. I'm not sure, but I don't know if I'll be able to set up everything for that yet. So if I can't, we'll continue programming. Let's see, what would be something good to work on next? Well, we might as well move on to the second player. That's something obvious we can do. So we'll work on ending the turn and then transitioning to player 2. You'll notice that in the move option calculator, it doesn't take into account reversing, or because we need to rotate all of the move options 180 degrees for the second player because they are looking the other way. So we'll get to that. Oh, good thing we passed this owner player. And then also this turn manager needs to finish up. Maybe we'll even do some networking, I'm not sure. Thanks, Steph. I'm pretty happy with it. Of course, the graphics are nothing exciting yet, but we'll get to that. Anyway, I hope you all have a good evening, and I'll see you tomorrow. Bye-bye.